All right, let's get to coding. Okay, so I've got this actually. So this is an audio project that I'm doing. The idea of Helios. Let me just go to the GitHub. So the idea of Helios is a project I started last week. And yeah, it's a project designed to train and run a state-of-the-art unsupervised real-time audio generation system. It leverages an encoder-decoder VAE-like architecture to learn a latent representation of audio in a latent prior model, an RNN to generate or transform audio signals in real time. So then it just goes into a breakdown of what this is. You might notice that this was probably generated by ChatGPT, and you would be correct in that. You know, I don't know how many times I've said this, but like, you know, I like my hands, and I'm not a young guy, so I'd rather tell GPT or any other language model that's decent enough at coding to like write me up specific functions, and then you know, and then just implement those into my framework, and then just go from there. I think that's what a lot of people do who have experience in coding, and then like using that experience to code stuff with. Yeah, okay. Let me just, yeah, okay. Oop, yep. All right, closing out Twitch so we don't get an infinite loop. All right, and then, yeah, I mean, you know, like, essentially what I want to do here is I just want to take a whole bunch of David Bowie MP3s. Did I? Oh, yeah. Wait. No. Do I not? Okay. This is what I'm doing here. I'm just testing it with a very simple MP3. So the idea, the flow of this goes, you know, here's some example workflows. You prepare the data, you train the VAE, you train the prior, and then you generate. The issue is, like, on my local laptop, I've got a 3060 Ti on this bad boy. I've got a ROG by Asus. And on this GPU, I cannot train my prior. I can only train the VAE. The VAE is actually really small to train. If I go to Projects Helios, where'd you go? That laser cat lady. God, there's so many things. There's so many things yet to do, and like I think I was calling October Codetober because the coolest thing that I found about GPT 01 is that since it's much better at coding than 4.0 is, and of course, you know, I'm not talking about 03 yet, because like I haven't even really touched it because I've just sort of been just focused on other things. Plus it's Christmas and all that other stuff. You know, I got other stuff to do. Which, by the way, I had a great New Year, Christmas Eve, like daytime and nighttime or whatever. I hung out like all evening with some friends. That was really cool. So I hope that you all are doing something the same today or yesterday, depending on when you actually celebrate this holiday, or if you do it all. I mean, and if you don't, you know, Christmas in other parts of the world, which are not Christian or Catholic, they don't really, they're just another day. So I hope you have a good day if that's the case. All right, checkpoints, configs, data models, test. Okay, cool. So this is this is our file structure. And if you're wondering, how did I get ChatGPT to code me this? Why am I not using Devin or some other equally worked up and hussed up like building system to build out a model or like a project? Sorry. But essentially, what I do is I just ask ChatGPT when I'm done asking it the requirements and I get all that information that I need. I just say, hey, could you make me a an SH script for this? And it just grabs everything. Like, so just take everything that you just coded and write it all into an SH script, a bash script, or a bat if you're in Windows. And then, you know, like I can even have it set up the GitHub and set up the README. It did all of that. It set up all of this stuff in one go. And yeah. Right, conditional generation. There's other stuff that I wanted to add in the future to this, but right now I'm just trying to get around this one major error I've been hitting with the GRU. It's using a GRU for GRU. Yep. Oh, Geeks for Geeks, man. I haven't seen you guys in a while. March 2023, all right. So this is what a GRU is, essentially. You have a recurring unit. It's similar to an RNN, it's just gated, let's just say. That's the G, right? And it has an update and a reset and all this other stuff. So I'm not gonna get really too far into this one. Because to tell you the truth, I don't fully understand the GRU. And actually what I should do is I should take the time. So the process of calculating the current memory gate is a little different. First, the Hardemard product. I've heard of these, the Hardemard products. So element-wise multiplications of the Hardemard product. You know, and it's not that I have never done element-wise multiplication before. It's just that I've never called it the Hardemard product. And this is actually also another one of the reasons why domain knowledge is really important nowadays when you're prompting AI for stuff, because you've got to kind of know the best, most efficient way to ask it so that you get the results that you want. Because again, this is not AGI, and it's almost not even AI. It's not even really intelligence. It's just, you know, kind of riffing off the features learned from learning a language. So AL, artificial learning, you could say, at least I would call it AL instead of AI. Process of calculating current memory gate is a little different. First, the Hardemard product, the reset gate and the previously hidden state vector is calculated. Then this vector is parameterized and then added to the parameterized current input vector. Okay, so let's just break this down. So you've got, this is a single recurrent unit containing different gates. And this is just going over it over again, back through this recurring unit. The basic workflow of a gated, similar to that of a, blah, blah, blah. Gated recurrent consists of gates which modulate the current input and previous hidden state. So those gates essentially modulate, yes, which means that they change the frequency. They change one of the underlying frequencies of this, whatever signal it is, right? So in this case, in the case of like input and output on a neural network, all right, yeah, and that's the other thing. LSTMs, long short-term memory networks, also have a lot to do with GRUs. They were kind of, if I remember correctly, they were created around the same era. And, yep, okay, so we've got our update gate, Z, our reset gate, R, and our current memory gate, what is this, HT, it's super hard to read on my black screen. Reverse frowny face. It is often overlooked during a typical discussion on GRUs. It's incorporated into the reset gate, just like the input modulation gate is a subpart of the input gate, and is used to introduce some nonlinearity into the input and also make the input zero mean. Another reason to make it the thing I love about neural networks is this: they're really good at solving linear problems, but they're also good at solving nonlinear problems. It's just that you have to literally use a nonlinear function somewhere inside of the architecture. Like if you just put oh geez, what is that one? I could go over. I don't know if you guys want me to go over that. Shit, I'm not even looking at my chat. I should probably do that. Let's see. What do we got? Just looking at it on my phone. Is there anybody? Okay. Do I have anyone here? Wait, did I get disconnected? It was only 10 minutes? What? No. Okay. There we go. I'm really not sure what happened there on my phone. Okay, so there's nobody in the chat, which is fine. But I also kind of don't have any input back from anybody, so I'm just gonna keep going on my random walk through all of this. Okay, so yeah, here we go. So here is the nonlinearity that happens inside of neural networks. Sigmoid function, the tanh function. And if you remember from high school algebra, geometry, trigonometry, because, well, mainly trigonometry, but the tanh function, that's a popular one. But it is the hypertangent, I think it's called. Man, I'm trying to remember from a long time ago now. Don't ask me how old I am, or if you do, just be prepared to be surprised. So, all right, unlike LSTM, it consists of only 3 gates and does not maintain an internal cell state. So, yeah, the information which is stored in the internal cell state in an LSTM recurrent unit is incorporated into the hidden state. So that's where it goes. This is the collective information of, this collective information is passed on to the next GRU, and the different gates of the GRU are as described below: the update gate, the reset gate, and the current memory gate, right? So then, you might notice that I'm actually going through this document non-linearly, and that's kind of like how everybody goes through every document. Jesus Christ, I can't bring myself to not. I can't bring myself to put this on non-dark mode because I just like my eyes. So, okay, but the rest of this is like, it's just giving some examples of how that works out, and it kind of like, here's the thing. Do I really need to know exactly how a GRU works? No. In order to get done what I need to get done and get past some errors, I will learn some stuff about what a GRU works, how a GRU works while I'm working with it. So, okay. I think it's actually time to properly touch code, because yesterday I did plenty of touching grass. Yeah, so the VAE trains fine. And then we train off of the epoch 10. And what was the music that I actually...
Jeg vil si noe om mitt forhold til buss. Jeg hater buss. Ut fra Tønsberg til Sandefjord. Jeg burde reise til Drammen. Som sagt hater jeg buss, av ovennevnte grunner. Men hvis jeg møter en pensjonist som elsker buss...
Okay, so, what was that, Polish or something? Probably somebody could help me out with that later, if you comment. So, okay, so here we go. So essentially, what is this thing gonna do? What I planned on it doing was to be able to sort of like real-time modulate, neurally modulate my input. So I could just be like talking just as I am now, And then what's going to happen is I'm going to end up sounding like some sort of a remix or whatever of the sounds that you heard there, right? Because what does a neural network do? It grabs the features. And in some cases, it does like hierarchical. If you have like a very deep network, you can get very deep hierarchies of features. And so what ends up happening there is that you just get like, you get what you get. All right, we're going to do this on an A100. The only thing is that this A100 costs some creds, but I do have plenty of credits here. The problem is that I can't get around this error. So I just learned about, oh yeah, this guy, Randy. And let's turn YouTube off. Okay, so let's go back into contiguous versus non-contiguous. And again, like I said, sometimes you just don't know exactly what you're doing. You just kind of know an idea of what you should be doing, and then the rest of it just falls into line based off of actually doing it. So that's what I'm kind of doing here. Because truthfully, I'm not really the best person or even very experienced performing training on larger models or anything along those lines. Like I've trained toy instances, and I've seen stuff work, and I've had plenty of time to do all that stuff. So I've done that, but there's never something that I've been, okay, this is my model that I trained from scratch using XY, using these things. So I guess kind of like in a way this video or probably a series of videos will help me. I can just go back and summarize all these through AI and then like go over the parts that I need with AI again, and then take that out and pull that out and grab timelines and quite possibly write a scientific paper after I do tests, results, and blah, 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 just to see, what's going on. And then if I could afford it and whatever, I can actually just train another model as well, or, go to the second stage. But that's one of my biggest problems as well. Whenever I'm doing an exploration or something, I like to stay so much in the flow of everything that I find that it's hard for me to go back and then recreate everything that I've done into some text, into some documentation, or just even a record of what I've done. And that just definitely doesn't allow me to create any sort of scientific papers or anything along those lines. And that's definitely been one of my goals, is to write a scientific paper. And it's like, you're like, wait, what, about what? And it's like, I don't actually fully know what I really want to write. Like, I do know I want to write one. And it's like, I guess, when you don't do something for a long period of time, you like want to do it, but you just don't. It just builds up, and it becomes this thing that seems unreachable. I mean, I don't think anything is actually unreachable. So, but it can definitely seem that way. But taking this step by step should get there. So, okay, what is a contiguous versus a non-contiguous tensor? If you already know this, you get some kudos, but pretty much, from what I've just gathered reading this before, it allows you to place it's a tensor whose values are laid out in storage, starting from the rightmost dimension onwards. So essentially, it's stored in memory exactly how it's laid out, which means that you should end up with something like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, now if we look back at our code in Helios, we will see that what we're doing here. Okay, so this is the train pyre function, and this is the problem. This is the function where I'm having the problems. And so I've started to put in some prints here. If I could run this inside of VS Code, I mean, I probably can. There's probably some plugin somewhere where I'm like, I can run PyINB Colab off of here, control it through here, and then interact with it somehow or debug through it. I'm not sure, but essentially, the thing that I do not like about having to work from Colab or any other notebook is that I have to perform these. Debug contiguous. 1. Okay. Push it. And then over here, we're going to start it up again. And essentially, it's just not going to work again. But what should happen is I should get a one of these. I should get one of these errors, and it should show me if... Okay, so, torch load with weights only equals false, which is use a default pickle module implicitly. It's possible via checkpoint map location equals device. Wait, it's possible to what? To construct malicious pickle data while... Oh, okay. Okay. I'm not going to open an issue on GitHub for that. But, okay, this is essentially... What they're saying is this is bad security practice to just do a torch load off of a pickled checkpoint, which I understand. You know, people can put anything in those. But here we go. Input sequence shape. Torch size. 1352999. Okay, so those shapes are the same. I mean, what would be a contiguous shape inside of... All right, let's just go. Let's just go. Give me that A100. I don't think Gemini could help me any more than ChatGPT helped me here. Because, you know, essentially I tell ChatGPT, like, hey, this is all my source code. Hey, and this is my bug. It's saying something about it could be contiguous versus non-contiguous. Because that's the thing. It's like it says, it could be this. So it's kind of worse when your error output gives you hints as to what it could be. Because that actually throws off... GPT when it's trying to figure out what's going on. See, check this out. It's training the VAE now. Bam, bam, training that VAE, training it up. See our checkpoints coming in over here. Bam, look at all those checkpoints super quick. All right, the loss gets down from, you know, basically an order of magnitude in 10 epochs, which is fine. A little bit. Yeah, it starts to level out, right? Like we get that whole... sort of a thing. Okie doke. So, did this not? It didn't give me any extra output. What the smack? All right. Is this because it tried to like? Wait, hold on. Let's just take this step by step. So let's go into TrainPy and look at what it says. Right around 128, I should see my pro. I don't see it. Did this not? Oh, smack. That's because I updated the git. Git pull. Oh, git fetch. And did update. What was it? No, that's FFmpeg. FF only. That's the one. Not possible to fast forward. What was it then? Fetch. Jesus Christ, I'm probably... Yeah, this is not good. Okie doke. Alright, so... Here's another thing. Okay. That's what it was, I think. Git merge ff only. Oh, it's not something we can merge. Damn it. Oh, I hate this. Okay, let's just get through it. Okay, that's me setting up, that's the one. Okay, wait. I did all that stuff. Rebase. Origin main, push origin main. Let's go back through all my stuff. Okay, commit, fix, sub, update, glyphs, blah, blah, blah. That was all that other stuff. Great. Keygens, cloning, commits, training updates, add to the stream, contiguous stuff. You know, I shouldn't have updated. I should have just pulled first. I was just being dumb before I committed. Snap, dude. Snap. All right. Okay, let's do the real reading. You know, because I could just open up ChatGPT here. But I feel like they've given me the information that I need inside of these help things. And this is like what I originally loved about Linux. So let's see. The man pages. Yeah, man. Update. Remote refs along with associated. So git push all mirror tags, follow tags, blah, blah, blah. Those are all your options. Okie doke. Geez, this is the real problem why I do not, man, you know what? Just fuck it. Just. Okie doke. All right. This is not a question for 01. I mean, this is for 04. I accidentally. Oh, Jesus Christ. Accidentally. This is actually pretty embarrassing, but it's fine. You know, people expect you as a coder to just remember everything that you're supposed to be doing and all of like the specific syntax about everything. But I mean, do you even remember all the words that you're supposed to say when you're talking to somebody? Sometimes you have to look them up in your head, and you have a little bit of a brain fart, right? And I accidentally committed a git repo before pulling it, after updates on remote origin. And now it's telling me no fast forward. All right. Git fetch origin. Ugh. You know, it's probably because I'm not really a code reviewer type of a person. I don't do it much. So okay, git fetch origin. Yes. rebased. That's the one. Ref heads. Rebase. If there are conflicts during the rebase, there is none. Okay. Okie doke. All right. Now, after wasting all that time with this GPU, I'm going to disconnect and delete it. Man, I remember when it was so hard to get A100s. That was literally only like a year ago or two, year and a half ago. I kind of feel like with all this accelerating, following the acceleration process of AI has led me to have a different perception of time. Time pass. Okay. It got all the things. See, like this is also the thing I like about this lib. This what I've set up here with Helios. It's not got so many intense requirements either. But now we should just get some output. So let's let this train the VAE. While it's doing that, let's look at some memes. Yeah. I believe you have my stapler. Okay, that wasn't a successful thing, but at least we get... Oh. Oh. Wait a minute. I think what this is doing is... Also, Jesus Christ, 4.3 million... Wait, 43 million. 43.3 million is the shape. Oh my gosh. I think the problem is that I have a really large... I'm not going to finish that sentence, but that's my problem. I've got too many of them. So I think I'm allowed to say the word penis on this. Because it's a technical word, not slang, and not derogatory. It's just, how men from, like millennials and stuff like that, and I'm sure that even younger men do this. It's called a dick measuring contest, and what that means is, everybody pulls it out and decides to see which one is bigger, right? And when this was all getting started out, all the heavy AI competition between these large companies, I made a joke to my friends about this being a dick measuring contest, but it's actually, if you think about, it's not about size, it's about quantity. So how many parameters can you have if parameters were penises? So, Google comes out and they're like, we made this model that has 4 billion penises. And then it's like, whoa, that's a lot of penises. And then and then Meta comes out and we're like, oh, we trained a model with 18 billion penises, and before it was like, we were down in the low levels of penises, but as the escalation goes, that's the curve, that's the exponential curve that you see in AI. It's just tons of dick. If a penis was if a penis was a parameter, was one of these. So I'm thinking this number to me is very sus. It looks, and then this number right here, okay. This is 1.35, okay. You know what I'm thinking? I'm thinking I'm using the wrong sizes on things. So how could we make this? How could we make it? All right, let's do this. Okay. Okay. So I'm just gonna go back to my original Helios conversation. You guys get to see the Mojo prompty magic behind it. What? Well, that was dumb. Give me Helios. Okay. Yeah, it was a long conversation. So TLDR, I was like, hey, make this. Design a state-of-the-art unsupervised real-time audio generator which consists of a decoder and encoder architecture. The focus of the generator will be to generate a signal real-time, either dreaming a signal or performing a real-time audio to audio. The training data, I have ton of MP3s. RIAA, do not watch this. Do not content strike me for having MP3s. I am a pirate, but screw you. So this gave me some stuff, and then like I worked out a lot of other things, and then I asked. This is me asking for the SH script, which it did, and I put together the project. It was great, amazing, right? And then I think I asked. Oh yeah. I asked to write the README later, and working through stuff. So okay, I know it's always saying it could be non-contiguousness, but I just looked at some debug output, and I think maybe it's too big. I know I don't have to put these backticks, but I figure if we're training it, I at least want to train something that's going to be, that's going to put stuff in backticks for me, since, it's mainly just continuing a pattern. Okie doke. So I think that was, the sequence shape. And the other two lines were me trying to output, trying to printing. I wasn't trying to do anything, I was printing them. Bloop, bloop, blop, bloop, bleep, blop, bloop. Where we go. So, yeah. The stride. And I noticed it's super big. 43 million on one dimension. Insane. So where does the 32 come from? So we've got our config. This is my config YAML. YAML. Right? Okay. And I think it also needs to know, do I have any extra stuff in here that's like, I think there was something in here that was like, there we go. Where do we go in here? Contiguous. See, this is me just putting contiguous freaking everywhere because I'm like, it's not contiguous. But you know what? I think that was just me going in the wrong direction. These are like the rabbit holes that you can go down that lead to literally nowhere. There's no rabbit at the end of the hole. Like, just stop trying to follow it because, you tell it the output of the error and it's like, oh God, it's probably because it's saying contiguous. You just put contiguous on everything. I'm like, no, it's not the answer. It's not the answer, GPD. See, I almost called it Jippity there. Geez, watching too much Primogen. Is that a thing? Do people watch too much Primogen? I mean, I watched him the other day, and I sat there for like 4 hours, entertained, and I was on the chat too, like chatting him up. And it's like because he every once in a while goes back to the chat, so it's like a little dopamine boost when he goes back to the chat and like he sees what you said, and then you see your little chats like coming up or whatever at the top. But he can't see those chats unless he actually switches the screen back. So it's like when he switches the screen back, it's like you have to like time everything so that not only could you see your chat on the video, what you're trying to say, but then he can see it. So it's like, if you want him to say something that, and so it was funny, like somebody said to me, hi, Nate. And he was reading through stuff, and he literally he said, hi, Nate. That was funny. Anyway, I don't know. It's the little things. It's the little tiny dopamine hits that make your day. So, okay. So the weird thing is here too is that I trained the prior, right? And I think, is there anything outside of, okay, so the latent prior has a hidden size of 128 dimensions. Let's just, so wait a minute. What is the actual command here that I'm using? Config, okay, train prior only. So when I'm just doing this train prior, like, right. I'm saying like, dude, bro, dude, bro. My aunt was saying, you know, it's too much patriarchy in the way I talk. So maybe I should be like, listen up, sister. Got plenty of sisters, so I guess I'm kind of just used to saying sister as well. I don't know why I say bro so much. I don't even have a brother. Okay, so 128. Okay, so this is the only other thing where I'm just like, bam, this is going to be a hidden size. But essentially, I think what's going on here is the reason this is like blowing up to like 43.3 million is because it's not because of all the contiguous shit that I randomly did, but I think I'm going to probably have to take that out. Because it should technically already be in contiguous space. And I don't even know if that's the whole, you know, like, do we have to really put stuff contiguously? Because that's like, you know, but here's the thing. I've already sort of gone in that direction. So going back out of that direction is, it's like, should everything be in some contiguous format? I do not know. But it's probably not because it was not contiguous. It's probably something else. So I think that like going back through this and just being like, okay, well, let's just take contiguous out of everything. Okay. Besides that, I'm sick of saying this word, contiguous. All right, so then now, what do I want to do? I want to say, yeah, blah, blah, blah. I loaded all this stuff. That's great. Super, super, super cool. While I'm doing this, just delete and disconnect my runtime because it doesn't even matter because I have to download it all from GitHub again, update it, blah, blah, blah. Which I think is fine, but sometimes it has the notebook stuff has weird things when you don't just like fully reset the state memory and then anyway. Okay. So now that I'm rid of this random rabbit hole thing, I could always put it back by just putting contiguous back on friggin' everything. But I don't think that's gonna be necessary. Okay. So now then, because I think it's probably already contiguous. That's the thing. Input sequence has 0 time steps, incremental. Okay, that's fine. The hidden size. So I'll just say, here is the current state of my train prior. Here's my current updated train prior. I have to say the word updated when I'm talking to GPT, because if it doesn't see that, it's gonna like ignore the rest of my code changes that I've made. Here is the updated train function. You might notice I've taken off the excessive dot contiguous function because I don't think that is fixing anything. I do notice that we're using 128 hidden size, and that maybe, may be, by be. Why? We are seeing this error and a very large parameter explosion okay. Random chunking, crafting, chunking, chunk strategy. Essentially, your encoder is producing one large latent sequence for the entire set, the entire data set, or for a very large audio segment. And then you're trying to train a recurrent prior on all those frames. Yeah, okay. Okay, but I feel like it does do that. It does do the chunking. So break the latent sequence into manageable chunks. No. Okay, so essentially all I've got to do. Okay, it seems to. Should we downsample? Does minimal downsampling, you get latent frames. The code is fine logically, but you're generating extremely large latent sequence. These smaller segments or chunk the final latent sequence to R and N. Process it in parts. Okay, we just need to use smaller segments then. But what is it? What did it actually say about my question about the 128? So instead of training on one big sequence, blah 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 blah. Where it doesn't even say yes, yes. Okay. The concatenation of all latents. The code concatenates latents from every audio file into one big tensor. If your data set has many files or long files, you end up with a massive time dimension. I mean, okay, so it's taking the entire, so why do I even, all right, so there's this whole thing where it's like supposed to be setting up a, is this, there's nothing in here. Oh, okay, yeah, it did. So, look. Yeah, I mean, I don't even hear anything there. But let's just see if like sort of near the middle of Ziggy Stardust. I know, Bowie, I'm sorry. Is this even? Weird, okay. So first off, there might be silence in my wave files. You're gonna have to check that one out. Okay, so the problem is that it's taking everything and it's putting back into, if your data set has many, use a shorter, break the latent sequence into manageable chunks instead of training on one big sequence. But wait. So wait a minute. I think you've forgotten the entire flow of this. Let's review. There is a system already to prepare the data into super small chunks, and that is what's getting fed to the train function, which means we're breaking it down already, saving it into separate wave files, then for training on priors, we're gluing those files back together. What the fuck? I thought this was supposed to be training a real-time audio generator, not something that recursively generates an entire library of music. Library. Could we not do the gluing together of the training data and leave it chunked as it is coming from the files? Each one has a wave and a JSON. Shit's cray. All right. Pi. Yeah, train.py. Okay. Okay. Is a refactor. Logic to avoid concatenating all latent sequences to one giant tensor. Instead, each file's latent sequence is treated as an individual chunk, the same way each file chunk is a chunk for the VAE. Create a small latent data set for the prior. Each item in the data set is this latent sequence, 1T latent dim, so that's 1 time, this is the batch size, time, and then the latent dimensions. So this is the tensor, it's essentially saying, from a single audio file. Then we use a data loader to iterate over these chunks in training. What this solves. We no longer glue all latents together in a massive sequence. Each file's latent sequence is processed on its own, just like how VAE's treating sees the files as separate items. Updated train.py. So, used for VAE training. Yes, this was my data set thing. And I think if you could see here, I have data preparation. So, oh, wait a minute, what the fuck? Derp, derpy, derp, derp, derp. Okay. Is... Yeah. Yeah, I mean, it already, okay, so it doesn't have to assume any of that stuff. You know what? When in doubt, use the diff. So here's my orig, right? And then here's what GPT wrote. GPT! Okay, you added some comments. All right. Oh, you added some more comments. That's great. What are you, a Gen Z coder? This is your update to the... Okay, add more commenting. And add... What? Okay, so it's a latent data set. Each item init, torch device, CUDA, encoder, decoder, blah, 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 blah. Collate. It removed 47. All right, you know what? Let's just go ahead and run this. I mean, training the prior, collate latents, list of latent sequences, each shape, blah, blah, blah. For simpler prior training is let's process them one at a time, batch size equals 1. But if you want to handle multiple at once, you'll need to handle variable sequence lengths. We'll just return them as is a list of T data. The data loader will pass individually for batch size 1 if batch size is equal to 1. So that means we have batching on these. So the training the prior, instead of merging everything into one giant tensor, we create a files latent sequence separate training example, iterate over them using a data loader with batch size equals 1. Create the data set, BAP, from the VAE checkpoint, the training index. Is that a thing? Do we have a training index? Yeah, okay, that's already there. Okay. Loader equals data loader, latent data set, blah, 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 blah. Okay, I feel like we already have a data loader thing going on here. Yeah. Yeah, it's already, okay. Collate fn equals collate latents, which is going to be set to false, yes? Wait, what? Oh, the collation function, okay. That's an extra function that they put on top of there. I'm sorry I'm reading this all in that coloring. Let's just go ahead and, okay, so git status. Oh, look, I've modified train. How have I modified train? And in order to know, I can do git diff. Okay. Okay, just taking off the contiguousnesses. Okay, cool. So what I'm going to do is I'm going to git commit decontiguizing. I spell it with a Z because I'm from the United States and not the UK. Okay, decontiguizing. All right, so now let's just go in and go BAP. Okay. All right, there's my data loader stuff. Those aren't errors. Okay, save that. Now, so technically if we run a git diff now, the only reason I use the online git diff checker, by the way, is because it's just nice to, you know, not have to save any files or do anything like that, to just do a tertiary check. Okay. So the entire train prior function is gone, which is important because I think that's the entire function was just wrong. It was just wrongly assumed that that's what I wanted to do, is glue everything together. Like, dude, what are you on right now, right? All right, so git commit train prior pivot fix, hit push. So, I mean, I was asking for help from a person who's gotten some experience with this stuff before, but here's the thing with okay, coding and referencing, right? Now, right, okay, obviously this is gonna sound weird because I'm using ChatGPT, right? But it's not that I don't know everything that it's doing, okay? It's just that I'm not typing it myself, and I'm not going to look up how to use every single one of these things, etc. Because, you know, I'm not trying to get down to that level. That's not the level I'm trying to learn at. Now, those things will come along as I keep going. So, I mean, like I said before, the point is just doing it, and then as you do it, you learn. Okay. Did we commit it? Did we push it? Yeah, we did push it, okay. It's pushed. Push. All right, let's go ahead. Let's go ahead and go again. Running everything, baby. I mean, okay, this is what I want it to be doing, you know, at the end of the day. I want it to be like singing to me in like I want to be talking and it's going to be like like it probably won't sound like any language, right? But at the same time, it'll be what it knows, the features it knows of that MP3, but the closest approximation of that to what I'm actually saying. It's gonna sound weird as hell. Okay. Okay, so, like, shouldn't the training go faster on this as well? And then if this works, oh my gosh, if this works, oh, okay, there's my future warning. Could you please work this time? Oh, you're not telling me continue. It's working. Okay. Oh, okay. That's a pretty steep loss curve. All right. And I used super small. Okay, so this is the other thing. I didn't change. What am I doing here? This. Oh my gosh! I should actually be able to train this on my own. This is why. This is why I wasn't able to train it on my 3060. Okay. All right. So essentially, I don't even really need to do this anymore. I can just really go back to not using an A100. Okay, because this is going to be faster anyway, because I don't have to do a git update every single time. Yeah, sorry. You're gone. Check, give me check. Who sent me messages? Oh. Aww. Merry Christmas. Yeah. Sending some videos of my time out yesterday. One of my friends, Paul, dude, he makes ice cream. Oh my gosh. This ice cream was so good. It was delicious. Très superbe. Yeah, like, oh, and also all yesterday, je ne parle français. Un peu. But, you know, I don't speak it much. Hablo español. That's pretty cool. That's fun. And I'm very fluent in that. Castellano. Okay, so we got our latent dimension down to like 32. I suppose we should we should probably turn that up a bit. Like, what was the original latent dimension on this? Latent dim. Wait. YAML. Let's go. Let's do it. Oh, no. I think it put the YAML. Yeah, there we go. Okay, so batch size 8, latent dim 64, and I think I changed so maybe we can change this back to batch size of 8 and change the latent dim back to 64. Oh my gosh, if this runs. Okay. So obviously I'm still gonna update the this. But I probably don't need okay. Actually, you know what? Let's just keep going in this format. But we're gonna turn down back to down. We're gonna change this back to a T4, an L4, an A1 CPU, TPUs. Jeez. I don't think we. I think it's a T4, and the A100 is like probably the most. I mean, what's the RAM on the A100? Like 28 gigs or something? Some outrageous amount. We definitely don't need that much just to be, you know, doing some simpletonsness. All right, so git commit am. OMG, it's effing working. Yes. Okay. Git push. Let's go. All right. Let's run all this again. Okie doke. So, I mean, as you can see, I could have sat there and spent God knows how many hours trying to figure out all the stuff that happened over here with all this. Well, with all this train stuff, right? But like, is it really worth it for me? Because are those my mistakes? They are not my mistakes. Therefore, it is essentially impossible for me to learn from those mistakes. The only mistake that I did was when I asked it specifically what to make me. I didn't specify clearly enough that that is exactly what I wanted. And that's the thing about even O3, right? No matter how deep you go into all of these, the LLM-based technology, it will always be like the genie in the bottle, right? Or rather the genie out of the bottle. You know, genie, the standard genie, right? The Aladdin genie or whatever, Aladdin. This guy gives you 3 wishes, right? And then he's like, oh, but, you know, be careful what you wish for. And why does he say that? Because he's just a program. The genie is just like, it's like a demon. The original version of the word demon, the daemon. Okay, if you get biblical with it or whatever, right? So a genie is like, it'll do what you say, but if you do not specify every detail of exactly what you want, those details will be random. Usually in the stories, they're like random in a very ironic sort of a way, like, oh, you know, hey, you said you wanted your girlfriend back from the dead, but now she's a zombie. Because you didn't specify that you wanted her to be alive like she was before. You didn't say that, and no one's going to assume that. They're just going to say exactly what you did, and it's going to take like the most statistically easy and fastest way to get there. So, you know, you end up living with a zombie girlfriend. Well, I mean, luckily, this thing gives you more than 3 wishes, right? Let's see, this is done, okay. All right, so we got 5 epochs of training done on our prior. How big is our priors? Priors models. Huh, so small. Oh, so small. Okay. This means obviously we could definitely run this on our thing. But I'm kind of liking this. I'm kind of liking this notebook format, and I kind of wanted to finish it because I didn't even get through the rest of that stuff anyway. So, prior checkpoint, prior final length, seconds equals 10. Okay, so let's just try this dream mode. Let's see what this is gonna sound horrible. I'm gonna have to turn down my speakers or something, or turn down my headset. Run the priors. Cross your fingers and run it. Yeet. Okay. Oh wait, is this supposed to? Where is inference actually supposed to output stuff? And is inference actually properly set up for this? Because did inference not get the memo that train got? Okay. Okay, assume each latent frame corresponds to a smaller chunk of audio. Here we must define a relationship between latent steps and audio length. Let's assume that the encoder downsamples by a factor of 8 each time. You know what? This is old stuff. Great job at fixing your own slop. All right, so now here's that's not prior training, that's priors. Because if you say prior training, that means be from before. Okay, inference.py. And you know what? And just for free, just in case. I mean, okay, I say just in case there, and it should just automatically assume that I mean, let's complete the pattern and say he means just in case it also has the same problem. But there's some things that you can assume that it assumes, and there's other things that you cannot assume that it assumes, and that's the crux of the whole entire thing about LLMs. That's why, you know, you can't rely on them to think like a person. No major changes are strictly required for existing inference scripts. The model interface encoder-decoder prior remains the same, so each current approach dreamed audio with prior generated encoding works as before. You can keep using, yeah. Could you adjust number of steps calculation? Currently estimates steps. This is a rough heuristic based on the assumed downsampling factor, 3 layers times stride equals 2, giving 2 to the third equals 8 times 32, which is your new training approach. With your new training approach, shorter segments, different encoder, this might not match reality anymore. If you're reduced, that's actually what I thought. I was like, why is that 32 hard-coded in there? You know, anytime you see a number that's hard-coded in somewhere, that's kind of like a red, not a red flag, so to speak, because like, you know, those aren't hard-coded. But when you see something like yay, 8 times 32, and then it's like a big explanation of what each of those things mean. Okay. So you can increase or decrease steps manually until you get the desired output or quality. For instance, steps equals int length seconds times 32. If you suspect each latent frame is blah blah blah, bleep bleep blah bleep blah bleep bloop, drastically change the latent dimension or hidden size during training, none of this should break inference. But you must ensure the matching dimension of latent dim equals config model latent dim. Change the model architecture, add more layers, change the RNN in a transformer. You need to be matching generate. Okay, so, you know, in the end, we're not trying to look for like, you know, a long-term relationships, right? Because if you think about neural networks or neural network architectures as like Tinder dating, you know, people are on there for different reasons, right? Some people are just looking for a quick thing. Some people are looking for a long-term relationship, and then there's like everything in between those two things, right? A transformer is one of those people who uses Tinder looking for long-term relationships, because what it's trying to do is it's trying to match patterns across a very long sequence, and that's like one of the main reasons why transformers excel over traditional GRU, LSTM, and all that other stuff. So while it is a recurring neural network, it is not short on memory. All right, so blah, 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 blah. So technically, like, this is just a GRU, right? I'm not using a transformer here, so it's probably why I also don't need an A100. It's just, oh, yeah. What was it trying to figure out here before? Where does it actually output the audio? Oh, generated wave. Okay. It'll just make a directory called generated. Oh, whoa, buddy. Encode process. Oh, snap, snip, snap, snap. Okay. Prior state, block, blick, black, bloop. Okay. So, I tried to run it and got this error. I mean, there's a lot of stuff going on there. In each of the frames, unknown function. Root causes that torch audio save expects a 2D tensor of shape channel in it. Your code passing a 3D tensor, you just need to squeeze out the extra. Okay, so audio is currently 1.1 below is a minimal fix if you're in your inference scripts right before calling torch audio save. Okay. Yeah, I think I've seen this before when working with stable audio, the stable audio comfy UI node. So let's just do that. Let's go. Squeeze it. For those of you who do not know what yeet is, because you're from my generation, let Merriam-Webster tell you what it is. It's a slang word that functions broadly with the meaning to throw, but this is especially used to emphasize forcefulness and a lack of concern for the thing being thrown. So, I mean, yeah, you don't yeet something if you're worried that it might break. Yeet is also used as an interjection, most often to express excitement or enthusiasm. So I would say that I used yeet correctly here because, look, I'm squeezing it. I'm throwing it out. I'm throwing that batch dimension out of my freaking tensor. Get out of there. Yeet! And I don't even care where it goes, if it breaks or anything like that. It's just data. It ain't going to break. So, okay. I feel like we should, okay, I mean, like, for me, okay. I've got tons of data in here, which is kind of why I'm like, all right, let's just git commit am yeet inference squeeze double. Yeah, I don't even know what I'm saying anymore. Git push. Okay. Let's oh, next time, let's see what we're gonna do. Next time, we're fits to, yep, get rid of all of it. So next time, what we're gonna do is we're gonna watch the memory. We're gonna see how much memory this takes up, because yeah. And we went back to 64, a latent dimension of 64, and a batch size of 8. So that's always there. Meanwhile, let's keep going here. So stupid. Oh my gosh. This is so many code bases. Yeah, you're getting the thing. Just the top of Zucker. The way he's smiling. Oh, snap. Dude, yes, yeah. This is a good one. I did this one. I was running it on my phone. All kinds of sloppiness, all kinds of super sloppiness. And like, write a poem for me. It's like, poem. Get. Oh shit. Okay, where'd you go? Oh, and what did this look like? It went up to 32 gigs. I only ever used 0 GPU. Look at all those compute units. Oh my gosh. Got so many compute units. I like how they save up. Because like I literally haven't been using this in forever. Gotta use some of these compute units on something, right? Okay, where's my generated audio? Oh my god, this is gonna be horrible. I know it. I know it's gonna be bad. Okay, first, let's do this. Yeah. Oh, it's just it didn't do 10 seconds. We got some math wrong, I think. We got some math wrong. All right, I'm gonna go get some toast. I'm gonna make me some toast. So I'll like be back later or whatever's. So you guys stay frosty. It's Christmas, and you know, like I was saying before, 2 roads diverged in a yellow wood. So if your AI ain't frosty, then it ain't no good. That's my poem. Peace.